Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a very important technique in machine learning called as feature scaling. Even before I proceed to talk about what exactly is feature scaling, what are the different topics, what are the different techniques that we can use under feature scaling, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking the simple question, what exactly do we mean by feature scaling and why do we have to scale the features? Feature scaling is one of the most important data pre-processing steps in machine learning. I repeat, feature scaling is one of the most important data pre-processing steps in machine learning. Algorithms that compute distances, example, clustering-based algorithms, when these algorithms that compute distances between the features are used, these algorithms are biased towards numerically large values if the data is not scaled. What that means is, typically when we build a machine learning algorithm, we tend to use variables like age and income. When we talk about income, typically a customer's income could be 25,000 or let's say 50,000, or it could also be 1 lakh or more than 1 lakh. These are 5-digit numbers or more than 5-digit numbers. However, when you look at the person's age, it could be 25 years. When you use these two variables, the algorithm tends to be biased towards income simply because it has larger values as compared to age. So a variable like income may be given undue importance in learning the characteristics of the data as compared to age. This typically leads to low performance, low accuracy, and biased results. To avoid this, what we do is we tend to scale the data. When we use certain tree-based algorithms, it could be any of the decision tree algorithms, may it be Shade, may it be CART, may it be Quest, may it be C5.0. Any of these algorithms are fairly insensitive to the scaling of the features. So when we are using decision tree, we don't need to scale the data. However, there are many algorithms wherein feature scaling becomes very important. Let's now proceed to understand some of the important advantages of feature scaling. There are 3 main advantages of feature scaling. First, feature scaling helps machine learning and deep learning algorithms train and converge faster. Secondly, feature scaling enhances the performance of machine learning models. And thirdly, the accuracy of the model will improve after feature scaling. With this background, let's now try to understand some of the important techniques that can be used to do feature scaling. Typically, there are 2 useful techniques. The first useful technique is normalization, and the second technique that we use under feature scaling is called as standardization. What exactly is the difference between normalization and standardization? Let's look at this point by point. The first most important point when we talk about normalization is that in the case of normalization, minimum and maximum values of a feature are used for scaling. We just use minimum and maximum. Compare this with standardization. In the case of standardization, we use mean and standard deviation for scaling. The second important point under normalization is that normalization is used when the features are of different scales. Standardization, on the other hand, is used when we want to ensure a zero mean and unit standard deviation. Third point, when we normalize the data, the range for the data will be between 0 and 1 or -1 and 1. There are different types of normalization that we can use. When we use standardization, it is not bounded to a certain range. Let's now look at the fourth point. Normalization is really affected by outliers. So this is one important point. Normalization is affected by outliers. On the other hand, when we look at standardization, standardization is not affected by outliers. The fifth point, if you happen to use Python, there is a machine learning library called as scikit-learn. Scikit-learn provides a transformer called min-max scaler for normalization. The same scikit-learn library provides a transformer called as standard scaler for standardization. Let's now look at the seventh point. Normalization is useful when we don't know about the distribution. When it comes to standardization, standardization is used when the feature distribution is normal or Gaussian. Standardization, remember, is based on the standard normal distribution. Lastly, normalization is often called as scaling normalization. When it comes to standardization, standardization is often referred to as the Z-score normalization. These are some of the important differences between normalization and standardization. Now, let's proceed to understand normalization and standardization with a simple example. As you can see here, I've taken 10 values for a variable called as x. This is the original score of a particular variable. I'd like to show you what exactly is standardization and what exactly is normalization, and how do we standardize a particular variable and how do we normalize the particular data using Excel. Even before I proceed to standardize and normalize the data, let me compute certain basic statistics. Firstly, we would need the minimum. To compute the minimum, I will be using a simple min function. Once I use the minimum function, I can specify the range. This will give me the minimum value of x. As you can see here, Excel has computed the minimum value for x as 112. Let's now proceed to calculate the maximum value of x. I can use the max function. Again, specify the range. Close the parenthesis and hit enter. The maximum value for the variable x is 148. So we have 112 as the minimum value for x and 148 as the maximum value of x. Now, let me compute the third important statistic, which is the mean. I'll use the function, namely average. Select the range of x, close the parenthesis and hit enter. You can see here, Excel displays a value of 129.8 as the average value of x. Now, the fourth important statistic that I would be using is range. Range is simply the difference between the maximum value and the minimum value. I already know that the maximum value is 148 and the minimum value is 112. When I subtract 148 from 112, rather other way around, when I subtract 112 from 148, I will get a range of 36. So maximum value minus the minimum value would be giving me a range of 36. Let's now proceed to calculate the standard deviation. You can use the formula here, standard deviation for population. I'll have to specify the range of x once again, close the parenthesis and hit enter. This will give me the standard deviation value. So I've computed 5 important statistics: minimum, maximum, the mean value, the range, and lastly, I've computed the standard deviation of the data. Using these basic statistics, we will be seeing how to standardize the data. Remember, X is my original variable. To standardize the data, all that I need to do is select a value, subtract the mean value, which is 129.8. Let me put this within the parenthesis. So what this would give me is the difference between X and the mean value. Once I take the difference, I will simply be dividing that difference with that of standard deviation. You can see here, we have already computed the standard deviation as 11.7. You can go ahead and hit enter. So the standardized score for 112 is -2. Before I go on to apply this for the rest of the variable, I would like to freeze cell number E2. I'll do the same thing for cell number G2. You can see here, the reason as to why I'm freezing or blocking E2 and G2 cells is because from each and every X value, I will have to subtract the mean and divide it by the same standard deviation value. Let me go ahead and apply the formula for the rest of the cells. You can see here, this is the standardized score. Now, this standardization I have calculated for 10 observations. The same principle works irrespective of the sample size. Now, what is very, very interesting about this particular variable is that, let me now show you the mean of this particular variable. If you just compute the average, specify the range, you're getting a mean value of 0. This is what standardization does. It considers a mean value of 0. Let's now proceed to look at what is the standard deviation of this particular variable. Standard deviation. Let me go ahead and select the standard deviation. You can see here, the standard deviation value is 1. So after standardization, we have ensured that the mean value of the standardized variable is 0 and the standard deviation value is 1. Now, let me proceed to show you how to normalize the data. Now, to normalize the data, what we need to do is take a particular value of X, subtract the minimum value of X. We have already computed the minimum value as 112. Let me put this in parentheses. So this is simply X minus the minimum value of X. You'll have to divide this by the range. Let me hit enter. I'm getting a value of 0. How does normalization work? The simple formula to normalize the data is X minus minimum value of X divided by the range of the X column. What I'll do is I will block cell number C2 as well as cell number E3. This is done because from each and every value of X, I will be subtracting the minimum value of X, and I'll also be dividing by the range of X. Let me now go ahead and hit enter. So the normalized score for 112 is 0. Let me now go ahead and apply the formula. You can see here, this is not necessary. This is what you are getting. So these are the normalized scores for the variable X. What is important here is when you look at the minimum value for the new variable that you have computed, the lowest value is 0. When you apply the max function on the same variable, close the parenthesis, you are getting a value of 1. So with normalization, the range will be between 0 and 1. So this is how we can standardize the data and normalize the data. In the case of standardization, I'm subtracting the mean value from each and every value and dividing by standard deviation. And in the case of normalization, I'm subtracting the minimum value and I'm dividing it by the range of that particular variable. There is an obvious question: when should I standardize the data and when should I normalize the data? Is it necessary for me to perform feature scaling under all circumstances? To explore this question, let me move on to the next sheet. Here, as you can see, there are 3 columns. There are certain algorithms when no scaling is used. I repeat, there are certain algorithms for which you don't need to do any feature scaling. There are certain other algorithms which perform much better when you standardize the data. And still, there are other algorithms for which normalization is preferred ahead of standardization. Let me give you a few examples when you don't need to scale the data. The first classic algorithm which requires no scaling, you don't need to use standardization or normalization. You can take the data as it is and go ahead and build a model, would be a decision tree model. Whether it is shade, CART, exhaustive shade, C5.0, or whether it is any other tree-based algorithm, you don't need to bother with scaling of the data. The second algorithm wherein you don't need to worry about scaling would be random forest. Similarly, you don't need to worry about scaling for any of the boosting techniques. Let's say you're using XGBoost. You don't need to worry about scaling there. Nextly, for any of the bagging techniques, again, you don't need to worry about scaling. The 6th point here is about logistic regression. Again, for logistic regression as an algorithm, you don't need to scale the variables. The last algorithm, which I would give as an example, wherein absolutely there is no need for scaling, would be naive-based algorithm. As a general thumb rule, remember, for tree-based algorithms like decision tree or random forest, or for that matter, even your boosting techniques or naive-based algorithm, you don't need to do any feature scaling. The next point here is, when should we standardize the data? Typically, when you're using a hardcore statistical technique or any of the machine learning algorithms, it is preferred that you standardize the data. Some of the examples wherein standardization works well would be the KNN algorithm. Similarly, K-means clustering algorithm also requires, and it performs better if you standardize. Nextly, you can also use standardization for the independent variables in the case of linear regression. Last but not the least, for PCA, that is principal component analysis, you need to standardize the data before subjecting them to principal component analysis extraction. So again, I'd like to repeat this point. For most of the statistical based algorithms, it is better that you standardize the data. Now let's proceed to understand normalization. When do we normalize the data? Normalization is a preferred technique over and above standardization, especially for artificial neural network. When you're using any of the neural network based algorithm or deep learning based algorithms, it is better to normalize the data. Let's suppose that you're working on CNN or convolutional neural network. Typically, we normalize the data, we don't standardize the data. One more classic example wherein it is required that you normalize the data would be when you're doing image processing. Simply because when you're talking about pixels and such things, it is better that you normalize the data so that the normalized scores will lie between 0 and 1. So any of the image processing activities, it could be image classification or image segmentation, it is better that you normalize the data. Typically, you might have observed when you're using Keras and TensorFlow, we tend to prefer to normalize the data because it is suitable for those libraries. So these are certain thumb rules and guidelines. When should you standardize the data and when should you normalize the data? To give you a very quick summary, don't worry about scaling and such things when you're using any of the tree-based algorithms. Worry about standardization if you're working with statistical methods like k-means algorithm or linear regression or PCA. You should always normalize the data if you're using neural network or deep learning or image processing. So with this, what we have done in today's video is at a very high level, we have tried to learn about feature scaling. Why should we scale the features? We have looked at some of the important advantages of feature scaling. Feature scaling helps machine learning and deep learning algorithms train and converge faster. It enhances the performance of the machine learning models. It improves the accuracy of the model. We have seen two important techniques for feature scaling, namely normalization and standardization. Then we proceed to look at a simple example as to how standardization works and how normalization works. We also saw some of the important properties of standardization and normalization. Further, we also looked at when do we need to scale the data, when do we not scale the data. I've given you a few pointers as to when standardization performs better, also some of the algorithms wherein normalization performs better. With this, I have come to the end of today's video. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much. Have a great day ahead.